This is Chris Maynor coming to you from the campus of Union University in Jackson, Tennessee. In this video, I want to introduce you to a general demand equation. You have seen, of course, a demand schedule, demand curve. We've looked at the direct and inverse demand equations. What we see here in this problem is what we sometimes refer to as a general demand equation or general demand function. An economic consultant for X Corp estimated the demand function for the firm's product to be quantity demanded equals 12,000 minus 3p plus 4p sub y minus 1m plus 2a. Now what we have here is a general demand equation or general demand function, and what makes this general is essentially what we have is a direct demand equation with the addition of one or more shift parameters. In this case, we have the price of a related good, we have income and advertising, which are all shift parameters for demand. So a general demand equation is basically a direct demand with one or more shift parameters. And we're told that each of these variables have values. The price of the good is $200. The price of good Y is 15. The company uses 2,000 units of advertising, and consumer income is $10,000. You'll notice that we use the letter M here for income. It's a little strange, but that's what our textbook does. So the first thing we want to do is to use this information to derive the direct demand equation. Well, to do that, we simply take the general demand and we want to plug in, you've heard that term in math classes, we want to plug in the shift parameter values. So we keep the minus 3p, again p is the price of good X, but then we want to plug in the price of good Y, which is $15. We want to plug in the consumer income, and we want to plug in, I'll come down here, the amount of advertising, which is 2,000 units. And so we take our calculator out. Of course, 4 times 15 is 60, 1 times 10,000 is 10,000, 2 times 2,000 is 4,000. And we let the calculator do the rest of the work for us. And what we end up with is 6,060 minus 3p, which is the typical form of a direct demand equation. Quantity demanded on the left, price on the right. Of course, we could do a little algebra and solve for the inverse demand if we wanted to. The next question, we have the same general equation, but now we want to compute the amount of good X the consumer will purchase. Well, here we could take the direct demand that we computed in the previous question, part A, and simply plug in the value for P, the price of the good. Price of good X is $200. And so we would plug that in, and I believe with a little algebra and a little calculator help, we would get 5,460 units. And so consumers at a price of $200, given the other values for the shift parameters, would consume 5,460 units. Part C. Are goods X and Y substitutes or complements? Remember, this is the general demand equation for good X. And here we have the price of good X in the equation. So what we're looking at here to determine whether good X and Y are substitutes or complements, we want to focus on this term here, this positive 4 PY. This number 4, positive 4, is what we call a coefficient. And the value of that coefficient tells us the relationship between the price of good Y and the demand for good X. It's a positive 4. So as the price of good Y goes up, consumers of good X will buy more of that good. As the price of good Y goes up, say $1, then the quantity demanded of good X will go up by 4 times that, or 4 units. So what kind of relationship is that? Good X and Y, what kind of goods are these? If the price of one good goes up and the quantity of a related good also goes up, what do you have? You have substitutes. You got butter and margarine, Sprite and 7-Up, or do you have complements, peanut butter and jelly? Well, when you have a positive relationship between the price of a related good and the demand for another good, we're looking at substitutes. Substitutes. As the price of good Y, Sprite, goes up, what will happen to the demand for 7-Up? It will rise as people move away from 7-Up. They'll purchase more of the related good, Sprite. And so these two goods are substitutes. So if you look at this term here again, the price of the related good, if that coefficient is positive, then you're looking at substitute goods. If the coefficient is negative, less than 0, then you would have complements. Last question, is good X a normal or inferior good? Well, again, we want to focus on a coefficient. Normality and inferiority are based on how a good responds to changes in income. We'll notice that the income term has a -1 m, -1 times income. This negative coefficient tells us that as income goes up, people, consumers of this good, will buy less of that good. As income rises, consumption goes down. Well, what kind of good is that? Well, by definition, that's an inferior good. Inferior good, income, and demand have a negative relationship. So if this coefficient, we'll just call it C, the coefficient on income, if it is positive, then we have that should be in a normal good. If it's negative, we have an inferior good. So we can use the general demand equation not only to compute values, not only to derive direct demand, but we can use these coefficients to determine what kind of good we have and the relationship it has with other goods. This will be important when we get into the third week, the next week's lesson on elasticity. We'll see more how we can use these coefficients in the general demand equation.